right, friends, it's your boy, Mr. Shagney, coming at you with Unit 3, Lesson 6, Scaling an Area. So today in class, we talked about scaling a pattern block. And so it says, in class, your teacher will give you some pattern blocks. Work with your group to build the scale copies described in each question. So we're going to take the pattern blocks. And so we're going to start with the blue rhombus. So in case anyone is not aware, this is a rhombus. And so if this is what we start with, it's asking us to make a new rhombus where each side is twice as long as what we started with. So what we're going to do is we're going to, so if I wanted to double this side, I would have to put one next to it like that. But now I've only doubled one side. And so this I've doubled here, but now I need to double this length here. So I need to add, and I apologize for the cups here, need to add another row at the top. So now I have a 2 by 2 rhombus. And so in order to scale that, I need to have 1, 2, 3, 4 blocks. So this lesson is all about scaling an area. So if my first one, so I'm going to take these away. If the first area was 1 block, it only covered that much space. And so when I scaled it by a scale factor of 2, right? Notice that the area went from 1 to now 4. So you got to ask yourself, what is happening to the area when we scale an object by a scale factor of 2? Well, what's happening to the area is known as we are taking the square of that. So we're going to take our scale factor and we're going to square that. And we're going to multiply that by how many blocks we start with. So in this case, we started with 1 block. And because we started with 1 block, that means we're going to take 1 times the scale factor squared. So this one was 2 squared. That means 2 times 2. And then 2 times 2 is 4. 4 times 1 is 4. And that's what gives us that there. So this will work in every situation, but I'm still going to model for you. So now 3 times as long. So in this situation, if I want something 3 times as long, I'm going to have to add, that now this is adding to that. Sort of understanding of 3 times as long. So now I'm going to add this here, right? And then add that there. But now that's only a 3 by 2. I still need to make sure that the height is scaled by 3 because, 1 times 3 is 3. And now you can kind of see a pattern starting to form here. Right, so in this situation, we have a 3 by 3. So we went from 1 to now 9 blocks. So we're asking ourselves, if we covered 1 block, right? Now we're covering 9 blocks. Remember that 3, if we take the square of 3, that means 3 times 3, which equals 9, right? And 9 times 1, because that's what we started with, equals 9, which still gives us our number there. And then last but not least, we're going to scale this by 4. And so what I'm going to do here is I'm going to scale this by 4. So I'm going to add another row here. I'm going to continue that sort of pattern here. I'm going to add another row this way. And then I'm going to have to add another row at the top. Sorry, I am slowly doing this, right? So this might be a long video, but I want to make sure that you see that I'm scaling it. So now I went from 1 to now having 4, 8, 12, 16 blocks. So this one is 16 blocks. And if we take 4 and we square it, that means 4 times 4. We get 16. And we started with 1 block. So we can take that times 1. And that's going to also give us our 16, right? In case we cannot or don't have the ability to count, we take our original area, which was 1. So this is like, think about this as your original area, and then now your area is 16. So you square your scale factor, and then you multiply it by the original area, and that's going to tell you what's happened to the area of the figure. So I'm going to put these away, and now I'm going to get my green triangles out. So give me a second to put these away so I can get out my green triangles. and my green triangles. So in this one, how many green triangles blocks does it take to build a scaled copy of figure B? So figure B is 1, so I want to scale this, right? So that means I want to build the same shape, right? But I want to scale it by 2. So I'm going to put 1 here. I'm going to put 1 there. Maybe like that. And then put 1 at the top. So really, you should have something like that. So that is scaled. This is a 3. Now, so this is 4 blocks, right? So you can kind of see that the original pattern went from, you know, 1 of these, if you say that, and now it is scaled properly. So you're just redesigning that pattern. So this one would be 4. And remember, we're going to take the scale factor, which is 2 squared, which gives me 4. I started with 1 block, so I'd take it times that by the original area, and that gives me my outcome. Then I want to do this 3 times as long. So in this situation, I want to go ahead and scale this properly. So I'm going to put this again around. So here's my top, and I want to build outward. So I should have 3 there. And then I want to go ahead and I want it to be a flat base, right? So we'll do that. I know I'm kind of doing this upside down, and I apologize, but I want to show you. So you are adding these triangles here. So now I've made a larger triangle, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one is 9 blocks. And so again, 3 squared equals 9. And then I multiply that by the original area to get how much larger the new area is, which is 9 units. And then now I'm going to then make the next row. So I'm going to do that here. Do that here. Now again, I apologize for the sound that that's making. Want to try to make this as best I can, and it's not working. There we go. Here we go. I got one more to put on each side, I believe. For that does not necessarily fit the way I want it to. Let's see. Hold on, something's gone wrong here. That's 9. Ten, 11, 12, 13, 14. Yeah, it should fit like right in like this. So it should be, I apologize, it doesn't look perfect. Should be 16. I gotta organize this so it looks a little better. But, so fix this. Right, tighten that up. Tighten that up. gonna come out at an angle like that. So there we go. So it looks like that's better. So that's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this one is 16. I apologize that wasn't perfect. So 4 squared equals 16 times that by the original area equals 16. All right. And then so we're going to put these away, and then we're going to get out my trapezoids. So I apologize for the delay here. Then we're going to look at my trapezoid on the back. So I'm going to take my trapezoids now, and I'm taking my one trapezoid, and what I want to do with this is now I want to scale this. So some of us had a problem with this shape, so here's my trapezoid. So to scale this by a factor of 2, what I'm going to do is do this, right? So I want to take the original shape I had and remake that. So I'll put one on top like this. And so now you can see that that is scaled. The original one is scaled by 2, right? So this one is 4 blocks. And remember, it's 2 squared times 1. That would be 4. Scale factor of 3, what I'm going to do is take this pattern. I'm going to elaborate on that by building the sides that we need. So I'm going to put one here. One here, one there, one there, and one here. And that's 4, 5, 6, 7, 8, 9. So 3 squared, so that's 9 blocks. I apologize for that. 3 squared equals 9. And if we multiply that by the original one that we had, that tells us our new area, which is 9, right? And then a scale factor of 4. So what we're going to do is we're going to continue building around this shape here. So I apologize, it's getting a little lost off to the side there. I'm going to scoot it in a little bit. So I'm going to build a scale factor of 4. So, you know, maybe I want to keep it, yeah, like that, like so. Push it down a little bit. So we can do like this. And then upwards like this. And then like this. And down. Oh, that's not shape I need. Hopefully I have one more. I think I do. Yeah. So this will work out well perfectly. So that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in this one, 4 squared equals 16. 16 times my original 1 equals 16. So I'm going to put these shapes away, and then I am going to answer the rest of these questions, teaching you all a way that you can easily find the pattern given any shape, right? So this one we play with the manipulatives to kind of get this idea built out for this lesson. So it says, make a prediction. How many blocks would it take to build scale copies of these shapes using a scale factor of 5? So I'm going to use, let's use rhombus. So if I have the rhombus, right, if my scale factor is 5, or even for any of them, if my scale factor is 5, what I'm going to do is I'm going to square that, because I did that in every problem. 5 squared is 25. So I'm going to use 25 blocks because I started with the original area of 1, so I know my new area is going to be 25. It's going to take up 25 units. And then for 6, scale factor of 6 would be 6 squared. This means 6 times 6, which is 36. 36 times 1 equals 36. Okay? Now for the next activity, you're given new patterns, right? And so we can build these. So it says build a scaled copy of these if we wanted to. What I'm going to do is I'm going to teach you sort of, in the first activity we have 1 block, but notice in D there are 3 blocks to start out with. And in E there are 2 blocks. And in F there are 4 blocks, right? So if my scale factor says build a scaled copy of your assigned shape using a scale factor of 2, use the same shape blocks as in the original figure, how many blocks did it take? So in this situation, there are 3 rhombi, right? And you would be remaking that rhombus 3 times in this situation, or 2 times in this situation. So you'd be doubling each of these. So if I doubled this piece and then doubled that, you'd be adding, it's a rhombus, so you'd be adding 4 to each one of these. And in that situation, you would get 12. So an easier way of doing that is what you're going to do is you're going to take your scale factor, which we know is 2. So scale factor squared times number of blocks. So this is my formula that I'm going to use. Scale factor squared times number of blocks. So my scale factor in this one is 2. 2 squared times, in D, right? So we're doing this for D. In D, it's times 3 because that's how many blocks you start out with. That's your original area, right? And so we have 4 times 3, which equals 12, right? If I were doing E, I would do 4 times 2, which would be 8. And if I was doing F, it would be 4 times 4 because I have 4 original blocks. The scale factor is always squared, and then you just multiply by the original area. So the original area here is 4, the original area here is 2, and the original area here is 3. So in each of those cases, it changes the amount of area that's covered in your new pattern. So number 2 says your classmate thinks that the scale copies in the previous problem will each take 4 blocks to build. Do you agree or disagree? Explain your reasoning. So in this situation, I disagree because each pattern starts with more than 1 block. Okay? It says start building a scaled copy of your assigned figure using a scale factor of 3. So if your scale factor is 3, you're going to do scale factor squared times number of blocks in original. Right, so my original for D would be, I would take 3 squared times 3, because I have 3 blocks to start out with. So this represents 9 times 3. 9 times 3 is 27. For E, I would do 3 squared times 2. So this is 9 times 2, which equals 18. And for F, I would do 3 squared times 4. This is 9 times 4, which equals 36. Right? So that's where we're getting with this. And I apologize if you cannot see my handwriting here, or if I'm not zoomed in close enough. It says, how many blocks would it take to build scale copies of your figure using scale factors 4, 5, and 6? So I'm going to choose one here. So I'm going to choose 4. So if my scale factor is 4, so I'm going to do scale factor squared times number of blocks in original. And I really want to get to the point where you just realize that this is area, right? So scale factor squared times number of blocks in original, how much it covers, right? So this would be 4 squared times 3. 4 squared is 16, because that's 4 times 4 times 3. 16 times 3 would be 48. And then 4 squared, so that's for D. For E, 4 squared times 2, that's 16 times 2, which equals 32. And then in F, that's 4 squared times 4. That is 16 times 4, which equals 64. I want to check that. I just want to make sure that I'm not just doing mental math just to do it. So this is 64. So how is this, so the question 5 says, how is the pattern in this activity the same as the pattern you saw in the previous activity? So the similarities are scale factor squared times number of blocks. Differences, the pattern has more blocks. The patterns have different numbers of blocks. Okay? And so that's what we're doing there in that activity. In this activity, we were given, right? So in this activity, students were given a parallelogram or a triangle. And so the parallelogram I'm gonna draw up here. So this is a parallelogram. Students were given a parallelogram, and so basically a little triangle was here to show that if you move this over, so this was considered 5, and then the height was considered, I think the height was considered 2, so the base of that was 5, and that was 2. And then other students were given a triangle where the base of the triangle was 4 and the height was 5. So these were the two shapes that students were given in class, and each of them was given something different. And so you picked one and then we compared it. So we talked about how to find the base of these figures. Students reminded me that you could move this over here, and I know it's not perfect, to make a rectangle. And what they gathered from that is that to find, so I'm going to write parallelogram. To find the area for a parallelogram, we're going to do base times height. And I apologize that my H did not connect there. And for a triangle, I know that in a rectangle, so if I take a rectangle here, in a rectangle, if I were to cut at a diagonal, I would end up getting 2 triangles here. So what I know about a rectangle is I know that if I do base times height, I have to cut it in half because look, that's half of the full thing. So the area for this is half times the base times the height. And so that's what we used here. So in my scale factor of 1, I kept the base of the parallelogram the same. So I wrote P for parallelogram, which is 5. For triangle, the base is a base of 4. The height for the parallelogram is 2. And then the height for the triangle is 5. What I noticed in this pattern already is I noticed that the height of the triangle and the base of the parallelogram are the same size. To find area, I do 5 times 2, which is 10. And what I notice about this is that if I take half of 4, because half of the base is 2, which is half times 4 would be 2. 2 times 5 is also 10. So they give me the same area. So this is my original area. Now what I'm taking from this is now if the scale factor is 2, I'm wondering what's going to happen to the area. Well, in the last activity, what I did is I squared the area. So I squared the scale factor. I apologize on that wording. which gives me 4. So if I take 4 and I multiply it by this area, this should be 40. So now I'm going to check that. I'm going to check using the parallelogram because the parallelogram is pretty straightforward. So parallelogram's base, if I scaled this side by 2, that'd be 10. And if I scaled this side by 2, 2 times 2 is 4. 10 times 4 does give me 40. Now I'm going to plug in the side links for the triangle. 4 times 2 is 8, and 5 times 2 is 10. Half of 8 is 4, which gives me that number there, and then we multiply by 10, which gives me my area. So that's how that works. Now if we go here, we're going to square this number, which equals 9. I'm going to go back to my original area, which is when the scale factor is 1, and I'm going to multiply 10 times 9, which gives me 90. I'm going to plug in my numbers in the table. P stands for parallelogram. 5 times 3 would be 15. 4 times 3 would be 12. 2 times 3 would be 6. 5 times 3 would be 15. So 15 times 6, if I wanted to show that work there, 15 times 6 does give me 90. So that works out for both of them. Half. In this situation, we're doing half squared, which means a half times a half, which equals 1/4, right? So now I'm going to do 1/4 of 10. So I have 10 times 1/4. Apologize, the ink's running out on that pen. So a half times a 4th, right? Just keeping track of time here. This means 10/4. Then I could reduce that, right? So 10/4, 4 goes into 10 2 times with 2/4 left over, so this is 2.5, right? So this, I know the outcome is 2.5, so let's check that. If I take half of 5, I know half of 5 is 2.5. And if I take half of 4 is 2. If I take half of 2, that's 1. If I take half of 5, that's 2.5. 2.5 times 1 gives me 2.5, so that checks out. A third squared means 1/3 times 1/3, which equals 1/9, right? A ninth times 10 would just be this. 10 times 1/9 would be 10/9. And then I'm going to check that work. So P here would be 5/3. T here, what I'm going to do is take half of that. That'd be 2/3. I just reduced it to give me the outcome that I want. And then this would also be 2/3. And then T here would be 5/3. And so you're going to get 10/9 on both of those. And so that's what we did in this activity, because we're really trying to get to this point where we see the scale factor and we multiply it by the original area to see how the area is affected. So we take the scale factor, we square it, and then we take that number when it's squared and we multiply it by the original area to see how the area is affected in the scaled copy. The area is the same. So we talked that if I compare the results, the area is the same for both shapes. What is different? So the same, different. So what's different about the area? What's different about them is that their heights are different. And you could say they're different shapes and they have different formulas. Any of those things would apply. So now we're going to apply this table to my original. Remember, the area of the original of both of those was 10. So we're going to keep that in mind down here when we're applying this. So I'm going to look at my scale factor. I'm going to square it. 5 times 5 is 25. So that means that my new area is 25 times larger than it was here. So I'm going to take this and I'm going to multiply by 25, which gives me 250. Right? So my area here is 250. Then I'm going to take this, 3/5 times 3/5, which equals 9/25. I'm going to take my area, 10 times 9/25. Put a 1 here, right? I'm going to look for a pattern between numbers across from each other. I can't simplify here, but I can simplify here. So I'm going to simplify by dividing by 5 here. So this 5 goes into both of these. 5 times 2 gives me that. And then 5 times 5 gives me that. So now I have 2 times 9, which is 18. And then 5 times 1 is 5. So my area is 18/5. And I'm going to leave it like that. So that's what our lesson was today. In our last activity, it asked us about an exit ticket. And so a lot of us struggle with this. And so I'm going to walk through this. It says that Lynn has a drawing with an area of 20 inches squared. If she increases all the sides by a scale factor of 4, what will the new area be? So a lot of us wanted to do some extra work here. So think of this as our original area, right? So if this is our original area and we are scaling this shape by 4, we're thinking what happens to that area? So the first thing I'm going to do is I'm going to do 4 squared because I know I need to square the area. Or square the scale factor to find out how much larger the area will be. So 4 times 4, that's what this represents, which equals 16. I'm going to take this number and I'm going to multiply by the original area. So 16 times 20. And so when I multiply this, I'm going to do the work over here. So I'm really doing 16 times 2, which is 32, and I'm adding a 0. So this is 320 inches squared. So if I scale this shape by 4, that means that the area is going to become 16 times larger than it currently is. And so that's what we're doing in this problem. Down here it says, a lot of people thought that talked about this. Lynn has a drawing, right? Noah enlarged a photograph. A drawing and a photograph. So this is a photograph, or this is a drawing. This is a photograph. A photograph is a different problem. So enlarged a photograph by a scale factor of 6. The area of the enlarged photo is how many times as large as the area of the original? In this problem, what we're going to do is we're going to do 6 times 6, which equals 36. Because all we know is, the scale factor. So what we're going to do is we're going to take the scale factor squared, and the new area of the figure should be 36 times larger than the photograph was in the beginning. So that is the lesson that we did for today in class. I hope that you enjoyed this video. I hope this video is helpful in helping you understand what we're doing.